I'm very thankful to all of you who managed to join us. Some of you probably had to wake up earlier. Some of you had already finished the job day. And long time no see, because our last webinar that I have hosted was in December 2021. Since that day, we have been waiting for almost a year. And I think we here in S4GA are ready to share new information that I hope will be valuable for you today. Just to start with, I wish to welcome all the participants, S4GA partners, S4GA friends from all over the world. Currently, we already have more than 60 participants, and it's we can assume that we have people from probably more than 40 countries. And this is incredible that we can gather so many wonderful people, experts, specialists in their fields today. And I will do my best to make sure that you will get knowledge that can be of use for you, for your projects in the future. The main goal of my webinar is to actually show how easy it is to use solar airfield lighting and to add it to your current airfield lighting projects. I will try to fit entire webinar in 45 to 60 minutes, including Q&A session. I will go through my slides, tell you what I'm supposed to say today, and at the end we will do a Q&A where please, in the meantime, actually you can write your questions in the chat. My colleagues, they will gather all those questions and present to me at the very end. So I will go question by question and answer all of them. Also, I would like to add that today webinar is mostly for those who know a little bit about solar airfield lighting already, because I'm not going to cover basics. I'm not going to say what is solar airfield lighting actually is, how it is designed, how it is built. The goal for today is to show you how to design solar airfield lighting system for your airport project in 4 simple steps. So I hope you all are okay, in a good mood and doing fine. Let's move on to the next slide. Okay. So let me provide you with a brief overview of our plan for today. I'm going to answer 2 main questions. Number 1 is, how do I add solar-powered AGL to my airfield lighting design? And the second question is obviously, how can S4GA support me within my project? We are going to cover 4 steps of preparing solar airfield lighting design. Step 1, solar feasibility study. Step 2 is a cost comparison between conventional and solar systems. Step 3 is a solar AGL concept layout. And step 4 is a purchase specifications and other related documents. At the end, I will tell you about S4GA, about our portfolio. So I will remind you again, what is it that we are offering to our customers. I would strongly encourage you and I would recommend you to stay till the very end of the webinar, because I will be talking about possibility of free trial of S4GA solar systems in your airport. And when we finish all this, we will go to a Q&A session when I will be happy to cover all of your questions. I hope we will have enough time for that. So let's move forward. So how do I add solar solution to my airfield lighting design? Maybe before I go into that, I will say that for the last few years, we have been working with multiple airfield lighting designers, integrators. And the reason for that, I think, is that more and more airports face a choice between going conventional or solar airfield lighting. In some cases, solar choice is obvious, but in certain situations, conventional lighting is actually a preferred option. I do not believe, and we never, as S4GA, we never claim that solar airfield lighting is for every airport. But there are a particular group of airports where solar is actually a perfect fit. In recent 24 months, we have noticed a significant increase in amount of consultants, airport designers who actually graduated S4GA Online Academy. For those of you who don't know that, we offer free of charge online academy where you can apply, and you can actually finish several study modules. They are online. You can do that remotely whenever you have a free time. At the end, you have an exam, and if you pass it successfully, then you are granted with a certificate. So this program was extremely successful, especially amongst consultants and designers. We believe that the reason for that is because, again, many airports today, they're considering using solar systems as the permanent and the primary systems in their airports. And what we also assume is that there is no established and existing methodology of how to actually, what kind of process shall a consultant follow in order to, or a designer, in order to add airfield lighting as an option, or as an alternative option to conventional, or as a primary option to the project. So how do we validate feasibility of solar system? What kind of documents do we need to do that? So when we offer this, customer at the end, when it's installed, customer is actually satisfied. So this was the reason why we thought, well, why don't we share the knowledge? Why don't we share how we do that in this S4GA? Because over the years, we have actually finalized the methodology that we follow in order to make sure that the solar system that is offered works fine in the given airport. What is the ideal airport where solar is a perfect fit? I would say it is a regional, commercial airport, or the military airbase with a limited flight traffic. By limited, I mean, imagine you have an airport where you have 6, 10, 15 flights per day. Sometimes it's only 2 flights per day. We have multiple airports of this kind in the world. And those airports, they have significantly less money and the budget because of less traffic. But today, when they go for runway lighting, they are mostly offered conventional system, which is very often more expensive than what they can afford. So as an example of successful project and installation, I'm going to share with you a story of the Campbelltown Airport, located in Scotland, in United Kingdom. The system in this airport has been designed by the company called RPS. And maybe instead of talking about this myself, I'm going to show you what actually the designer who was working on that is thinking about why he had selected solar option for this airport. I'm talking about Mr. Massimo Degni, who I had a pleasure of working with. And let me share a short video with you.
We have recently designed a solar AGL system at Campbelltown in Scotland. The no requirement of cable, which means there are no requirement for all the civil ducting and electrical room, CCR, distribution board, everything.
Sorry.
It's very, very simple. The most important is that the light is powered by energy from solar, and this is the best environmentally friendly equipment that we can use to achieve the carbon net zero.
So to sum up, I think there are 2 points. Number one, the technology is green and it allows airports to achieve net zero. The second point is the simplicity. Simplicity of installation, no electrical infrastructure network to run a solar system. Just to summarize this project for you, the airport located in Scotland. So geographically, this is not, or it seems like the place where solar system might not work well. However, because of the efficiency of solar system provided by S4GA, it works there very well, perfectly. The runway length is about 3,000 meters. We installed the system in 2021. I have to manage here that the consultancy company, the designer was RPS, and particularly Mr. Massimo Denny. And the installation was perfectly executed by our representative in UK, Devhurst Airfield Services company. The scope of project, you can see right here. We have provided this airport with actually with all types of runway lights, including edge, threshold, and also taxiway edge lights that are installed on the taxiways and on the turnpaths. The system is equipped with individual light monitoring and remote control that is executed with the help of a software of the touchscreen monitor installed in ATC tower. And as the interesting fact about this installation is that we have an individual light monitoring where each light is monitored. We collect 27 parameters of each light in real time. So this allows airport personnel to monitor actually in the real time their system. Parameters that we can monitor is a battery level, solar charging speed, remote control, and so on and so forth. Another interesting fact for this airport is that they had there installed already old halogen puppies that they didn't want to exchange, but they requested us to provide the halogen puppies with remote control, so they can activate puppies from the ATC remotely. We have added to each puppy wireless relay. You can see it right here. So the signal from ATC is sent to the wireless relay that activates puppy and can change intensity. Another thing that we have specially designed for this airport was so-called puppy UPS. So this is a huge power bank where the energy is provided to the power bank. The cable from the power bank goes to the puppy. So in case of energy failure, because customer actually uses electrical grid to power the puppy, in case of the failure of this grid, this power bank will provide around 2 hours of operations. So the next question is, how can S4GA support my airfield design project? Let me refer to the Royal Institute of British Architects, or RIBA. This is a plan of work that organizes the process of briefing, a design, construction, and operating of infrastructure projects into 8 different stages. And it explains the stage outcomes and core tasks, and also information exchanges that requires at each stage. I will use this methodology to show you what kind of support Does S4GA provide at each and every stage? In most cases, consultants or designers' job start at stage 1 here, and it is finished on the stage 4. Sometimes designers are involved in the manufacturing and handover stages. So let me go through what we can do at each and every stage of the process. Before going into details of S4GA capabilities, let me refer to things that we need to do during a classical airfield lighting design project. In most cases, airport operator signs a contract with us, with consultants, with designers, where we are asked to provide them with a conceptual layout, estimated budget. We are asked to find suitable solution in terms of money, quality, lifespan, certification, etc. And at the end, we are expected as a designers to provide an airport with suitable documentation pack, or I would say a pre-tender tender specification that end user or airport can use to efficiently run purchasing of the equipment that has been designed. In some cases, as I said, designer also participates during the handover, during commissioning phase, where designer is expected to supervise whether what he has designed has been implemented by the contractor. And also, sometimes we know that designers are involved during the certification phase of the project. So what we have noticed is that sometimes designer is willing to offer an airport solar system as alternative to conventional. So airport operator can make a decision and select system that is suitable for him. But I think, or we believe, based on the conversations, on the cooperation that we have been through already, that there is a limited knowledge. In general, there is a limited knowledge on how shall consultant approach solar project design. Since this is obviously a different technology than conventional system, we often ask ourselves, shall we apply the same steps? Shall we do it differently? And there is no source of information publicly available for us so we can learn. And I think that subconsciously also, we try to validate this solution prior to offering it to our customers. We often, as S4GA, hear questions like, what is the battery autonomy, about backup power supply, about compliance. So what if we define questions like this? Is there a methodology to follow by us, by consultants, if we want to offer solar? And what kind of steps shall we take in order to assure our customers and ourselves as well that what we are offering is actually a feasible solution? So technically safe, compliant, and it will offer a long lifespan to the airport. With the time, we here in S4GA have developed 4 simple steps that allow us to validate feasibility of solar system for any airports. Sorry, for any airport. And what are those steps? So how can I validate if a solar system is a feasible option for my airport project? First, we start from verification that solar system could generate sufficient amount of energy to operate in my airport for as long as I need it and when I need it. I will repeat it. We need to verify whether solar system will generate sufficient amount of energy to operate in my airport for as long as I need it and when I need it. This is the absolute foundation of the solar project, because we need to make sure that the power supply is 100% reliable. Solar system can be designed in 4 simple steps. We start from a feasibility study, or we call it a solar feasibility study. This is the step where we validate whether or not solar system can operate as long as needed by the airport and when needed by the airport. After this question is answered and confirmed, we can move obviously to the step number 2. Solar system provides a significant savings for the airport. Why? I think you all know already is because there is a lack of complex infrastructure and very limited civil works. All these decrease a capital cost of solar system. But to make sure that cost benefit of solar system is real, together with a consultant, we prepare a cost comparison between solar and conventional 6.6 amp system. At this stage, this requires close cooperation with the designer. After step 2, if this is acceptable by the airport and airport also accepts cost benefit of solar system, we go to step 3, where again, in cooperation with the designer and with the airport itself, we prepare solar airfield lighting layout design that at the later stage will be used by the contractor to perform installation. After all this is agreed, we also provide a designer with a package of ready to be used purchase specifications, so airport can make a procurement of equipment that has been specified during the layout design phase. Let's speak about step 1, a feasibility study. This feasibility study stage answer a very important question. Will S4GA solar system meet requirements of my airports? When I say a requirement, I strictly mean operational amount of light that is required on a daily basis. So we start from check how many hours of lighting airport requires per day. Obviously, this is connected with the amount of flights. Let's say we have 10 flights per day. We estimate half an hour per one flight operation. 10 flights per day would give us 5 hours of lighting required for the particular airport. This question here obviously is the beginning of answering, and again I repeat it because I think it's very important, of the question if solar system can perform as long as I need it and when I need it. When this is clear, we go to calculation of maximum solar autonomy of S4GA system for this particular airport location. So we perform a simulation of a solar autonomy. I will speak in details about it on the next slide. When we have this, so this is amount of hours that solar system can perform without power blackout, and this is amount of hours that airport requires to operate solar system. We can compare those. If this number is higher than what airport requires, it means that the solar system operating operating hours, they meet requirements of the airport. If the answer is yes, we go to the step where we compare cost. Before we go into comparing cost, I will talk about how we calculate this feasibility study. So as the part of the feasibility study project, airport or the designer is provided with a comprehensive document, which is called solar feasibility study. It includes two parts. One is a result of solar study, and part two is the methodology. So this allows designer to really understand and appreciate how those results were achieved and adequately validate this information. When we talk about results, what you see here, this is the most important part of the results. It's actually show us amount of hours that are divided into 12 months of the year. So you can see January, February, March, and so on and so forth. So what you see here is this 4 hours, 12 hours, 24 hours. What it means? It means that if airport would operate, So if airport would operate its solar airfield lighting for not more than simulated hours, an entire system will operate without interruptions caused by energy blackout. Energy blackout means fully discharged battery. So this is a maximum daily amount of hours solar airfield lighting will operate in this airport without risk of blackout. Occasionally we are asked a question, okay, in case if airport occasionally requires to use solar airfield lighting system for more hours than simulated in solar autonomy part, so in this part, it is possible to use system occasionally due to large battery autonomy provided by the different intensity levels. So here you have also a calculation of how many hours can light operate, for example, at 60% intensity. So it's 60% intensity, light, regardless of the location, will operate 100 hours. So in case, for example, if in January, 1 or 2 or 3 days of January, airport suddenly requires to increase its operational hours from 4 to 8 or 12, no problem. They will use battery, energy stored in the battery to do that. This particular example was performed for a regional airport located in the south of United Kingdom. And as you can see, even there, if airport operates light at 60% intensity, they can allow, so amount of energy that we generate there actually allows us to operate lights every day for 4 hours a day. In the same airport, in April, they can operate even 16 hours per day. If you would like to see more details about how we do feasibility study, I encourage to visit our YouTube page. And there is a video called Feasibility Study of S4GA Solar System. My colleague, Olga, currently is sharing a link to this video. So after this webinar, you are welcome to watch it as well. So to sum up, when we work on the particular airport project, we always start from this. If those numbers here are accepted by the airport, only then we are moving forward. If those numbers, if let's say we're saying to the airport, this is a regional airport in UK that probably has 4, 5, 6 flights per day. If they would come to us and say, look, listen, in January, we need to fly 24 hours a day, every day. Well, then the answer of S4GA will be, you cannot use solar system. It's not for you, as it is. But because, as I said at the beginning, because we are targeting regional airports with a limited flight traffic, usually what we see right here is absolutely enough for them to cover their operational requirements. And you have to also remember that in case if they need to increase usage of the lights above solar autonomy that is forecasted, then they use battery autonomy. Let's move to the next point, which is obviously the most interesting for for the designers and consultants, it's a cost comparison. As I said, cost comparison requires close cooperation with airport consultant, and we are normally provided with a detailed bill of quantity and unit prices of every element of the conventional system. This way we can add solar option. As you can see right here, we have a conventional value, we have a solar value of the system. This way we can very transparently show to the customer where they save money on solar and how much money do they save. A majority of the savings are generated by lack of power supply infrastructure. That includes constant current regulators, transformers, cables, and another major part of the cost savings are the complex installation job. Just to show a couple examples, right? Like right here, we have a conventional system. You have a pricing for the CCRs, and here for solar, they're not applicable. Similar situation for conventional lighting. You need primary connector kit, secondary connector kit, cables, transformers, and you can see that all those numbers are empty here because solar system does not require all those elements. Trenching, ducting, this is all applicable to conventional, but it's not applicable to the solar. And in general, cost of installation of solar system is much cheaper than conventional because, well, the job is quicker and more simple and requires less people and less machines. The solar system can save you from around 30 to up to 60% of capital cost comparing to conventional system. Those numbers is just an example, so you can see where those where the saving is coming from. So in this case, for example, you can see that this part here is the cost of installation of conventional lighting system, and this part right here is the transformers, and you have transformers, you have CCRs. Those are the lights. Those are lighting fittings. So the majority of the savings comes from less complex installation process. When we finalize calculation of the cost comparison, we may go forward to solar AGL concept layout. S4GA has a team of experienced designers that can support you in preparation of ready-to-be-used airfield lighting drawings for any airport. Let us look at the example of this Brazilian municipal airport. This is a regional airport, commercial, that also sometimes accepts flights, military flights. And as long as this airport is shown on the Google map, we are capable to convert its image into a professional airfield lighting project that is fully compliant with local regulations. Obviously, this is again the moment where we closely cooperate with a designer. Sometimes we also cooperate with a local civil aviation authority to make sure that entire airport is designed in accordance with local regulations. So when lights are installed, airport is approved by CAA inspectors. Here you can see overall design of the entire runway and detailed bill of quantity for this particular airport. On the next pages, you can find detailed drawings of each part of the airport, including distances between the lights, and those distances can be further used by ground surveyors to depict lights, the location of lights in the real world, physically. As you can see here, we we show PAPI. You can see that, for example, here you can see there are different type of lights: threshold end light, taxiway edge for third path, white, yellow, runway edge light, PAPI. This is a solar engine right here. So this is just an example, but we can create similar professional drawing for every airport that is existing on the Google map. And this part we actually again offer as our consultant support package, and very often we do it as a part of the project, so free of charge for the consultant, so they can add it easily to their overall document for the customer. Purchase specification and tender documents. When we know how many lights, what type of lights do we need, obviously we need to prepare now requirements for the tender. So S4GA can provide a purchase specification, which is basically a description of each item that defines requirements of particular item that will be then presented to a contractor or whoever will be in charge of procurement. Again, let me get back to the RIBA project management stages. And let's go through this kind of support or kinds of supporting documents that we can provide at each and every stage. At the concept design, we always start from feasibility study. We provide cost comparison so customer can truly evaluate capital cost benefit of using solar system. And sometimes we also provide compliance matrix. This is the document that describes how S4GA system is compliant with local regulations. So there is actually the list of all requirements, local requirements, and aligned with the certificates that S4GA can provide to the local civil aviation authority. And this document is used to make sure that solar system is pre-approved at this stage of the conceptual design. At the end, we also can, at the end of this stage, we also can provide a budgetary quote. So again, consultant can pre-approve solar system with the customer. During spatial coordination stage, we go deeper into details. We prepare solar airfield lighting layout, and when this phase is over, we get this detailed bill of quantity where we know exactly how many lights, what types, do we need signs, what kind of letters shall be on those signs, how many wind direction indicators we need, if we need runway guard light, how we are going to power PAPI, and all the things, they are all defined during this solar airfield lighting layout. And at the technical design stage, we make sure that consultant is provided with a comprehensive purchase specification. This is here you see the example of a single page. Usually there is 2 or 3 pages for every product that is defined here at detailed bill of quantity. We also cooperate with a consultant or sometimes directly with end user at the handover, so commissioning stage. We provide certificate of compliance. And obviously we provide training. Sometimes it's a remote training, sometimes it's an in-field training. So our specialist travels to the site, and we spend 3, 4, 5 days sometimes with the customer to go around ALCMS system, runway lights, logic of all this, how it's operated, and so on and so forth. And on top of this, our customers are provided with product manuals that are divided into 3 groups. How to use the light, how to operate it, how to install it, how to install, how to use, and how to maintain. This is a unique feature of S4GA because most of our permanent solar systems are provided with ALCMS. and ALCMS provides us individual light monitoring. If customer interested, they can, in cooperation with us, provide us remote access to them to their LCMS. This way, S4GA service case technicians can, in real time, see and forecast the system status. And in case of any issues or failures, we sometimes know before customer what goes wrong, and we can then lead them towards fixing of these issues. Because, as I said, since we are capable to monitor 27 different parameters of each light, we very quickly identify issue of the problem and can provide customer with full instruction on how to solve the issue. Now let me go through a brief overview of S4GA and solar airfield lighting portfolio. Just a reminder, in S4GA, we operate almost on every continent today in more than 50 countries in 125 different installations. We provide you with world's safest runway lighting system because our system offers you zero probability of losing of entire runway lighting system due to power outage, since each light is independently powered. In every light you have two batteries. One battery is a main power source. Second battery is the secondary. All this and many other elements make this system extremely redundant to any failures. S4GA is a state-owned company, and entire portfolio is compliant with ICAO, EASA, and also today Australian Civil Aviation Authority. We also handle or possess certificates issued by local civil aviation authorities. Recently, we have been provided a certificate in Czech Republic and in Mexico. Portfolio. We today provide two types of systems in general. One is prepared, or one fits the requirements of a precision Cat 1 runways, where we are talking about complete portfolio of approach lighting system, and we use solar engines to power our PAPI. Runway lights, including elevated and inset. For those who wonder, we can power inset lights with a solar engine as well. Taxiway and apron, so taxiway, obstruction or unserviceable area lights, runway guard lights, taxiway retroreflective markers, solar wind direction indicator signs, and again, solar engine compact. This is a small solar engine that we use to power signs. And control and monitoring system that consists of LCMS basic or LCMS advanced with a control unit with a handheld controller used as a backup, different accessories. Also, we provide wireless controllers that, for example, we can use to control existing devices in the airport. Let's imagine we have in airport installed, here, for example, we have an apron light, that apron illumination that we would like to control wirelessly from our LCMS system. We simply provide wireless controller or we say wireless relay, and we send the signal to our wireless relay, and this device activates and change intensity of apron floodlights. So we can basically integrate any existing electrical equipment on the airfield within our control system. The second part of our portfolio is designed for non-precision or visual approach runway. Similar portfolio here, we have all lights required to build a simple approach, including runway threshold identification lights that are synchronized by GPS, LED PAPI produced by S4GA, powered by solar engine. For those who wonder, our PAPI can be powered by 230 volts, 24 volts DC and conventional 6.6 amp grid. So for those airports, for example, who decide to go for solar system on the runway, but would like to utilize existing 6.6 amp circuit for the PAPI, we can provide such product. Even when it is powered by 6.6 amp, we still can control it from ELCMS remotely. The rest of portfolio for non-precision looks similar as for precision airport runway, So all types of runway lights, white, yellow, red, threshold end light, taxiway signs, wind direction indicator. So anything you need to build a turnkey project for the small size, or let's say local, municipal, commercial runway, we have it all. This is pretty complex drawing, shows a philosophy of S4GA control system. I'm not going to talk about all of it today because this really requires a separate webinar. But what I can say is that how our control system works is that in the tower you have in the tower you have installed a control system that shows entire information to ATC personnel on the monitor. The same control system, with the help of the internet, can be connected to remote server where we, S4GA, or even customer from another city, can have access to the data of this particular airport. This control system operates lights using encrypted and authenticated control radio network. We can create as many virtual circuits, so we can group lights as we want, and we can separately control runway lights, PAPI, approach, taxiway. However we would like to group the lights, we can do that without limitations with the help of S4GA system. For those who would like to see more details about our control system, I encourage you to download our solar AGL brochure. On the last or almost the last page, this diagram exists. And we are slowly moving to the end of our webinar today. And I'm going to talk about free trial. Why we are offering free trials? Well, as I said at the beginning, we are very well aware of the fact that solar system is new technology. It's new. It has less installations today than conventional systems. Some installations that were performed by some of our competitors, they are unsuccessful for different reasons that I'm not going to cover today. So in different countries, in different customers, trust to solar system is different, although airports are interested, but they are cautious. So we in S4GA are very confident about our system. And in order to share this confidence with the customer, we came up with a way to do that by testing the system. So instead of trying to sell customer our system based on the brochure or on the cost comparison benefits, we say, we understand that the capital cost looks good. Certification looks good, and power supply seems to be reliable. But we respect the fact that somebody may still have a doubt simply because of lack of previous experience. And we say like this: let's install several lights This is what we actually do. We installed several lights, demo lights, with a complete ALCMS system at the airport that is interested in solar system. We leave this system for around 4 to 6 weeks. And during this week, or during this period, I'm sorry, we collect 27 data points from each light. So we collect enormous amount of data, and then we analyze this data and share it with the airport. And this data is supposed to confirm for the airport that what we have actually assumed, that the system is going to work there without power blackouts, is actually a true story. So how do we collect this data? 27 data points of each light is every hour is downloaded to the local LCMS system that is connected to internet. And then this data is transferred, uploaded to our cloud server, from where this data is uploaded to a local S4GA computer. And we, using this data, we can create all sorts of graphs that shows us actually level of battery. For example, you can see here that the system has been monitored from 30th of June until 14th of July. So for around 2 weeks. And this blue line is the battery level. So you can see that this system actually has been operated in a dusk to dawn mode. So lights were activated during nighttime and deactivated during daytime automatically. This way, customers didn't have to really care about this system, but it was automatically recording all data. So you can see that, for example, the battery during daytime was 100%, and it goes down during night, again goes up during daytime, and so on and so forth. And this happened every day. And here we also monitor how many, let's say, minutes or hours per day the system operates. This graph I can see here, it's not related to this project, but the thing is that we monitor also duration of operations and intensity level. This way, we confirm and validate that a feasibility study that was provided by S4GA at the beginning actually is confirmed or approved at the end by this trial. And from my experience, I can say that after this 6 weeks of engagement with the system, of seeing that everything is based on real data, the customer feels much more confident to proceed with us in the way of solar system. This is my last slide. I thank you very much for all the attention. Any of you is interested to perform free trial of S4GA system, please again contact us, and I hope we can agree on some interesting tests. Mark, thanks for the solidarity with Ukraine. You know what Russians are doing in Ukraine. I'm Ukrainian, for those who doesn't know. Those Russians is a terrorist state. S4GA actually do not provide any equipment to Russia. We will not do it ever. And thank you for the support from around the world. Thanks a lot. Bye-bye.